Today we're going to make a game that is funny at shows. Maybe we're going to let the helicopter pass. So she chose those graphics from Kenny, which are really nice, the abstract platformer graphics. And we're going to make a few mechanics from a platformer game. Okay, so right now you're in Godot. I'm just going to show you around the interface to get started.
Okay.
Here are the main screens. We're going to use two today, the 2D screen and the scripting one, which is where you will be writing the code. I prepared a game scene here in the scene tree. This is where you create nodes. You can see a couple here, the ground, the platforms. Those are the basic building blocks of your game in Godot. So it's like Lego blocks that you put together to make something more elaborate. The ground and platforms, for example, are tile maps that you can use to draw parts of your level. Okay, so here you have the file system. This is just the files that are in your project. I put them all there in a single directory and separated the player. Okay. On the right side, you're going to have an important piece, which is the inspector. When I select different nodes on the left, you can see the inspector update. It shows the properties of the node. It allows you to configure each node. We'll see how in a moment. And so the last thing I can show you is here you have the viewport where you can select things, you can draw, etc. At the top, you have a toolbar where you have a couple tools. So you have a tool to select objects, a tool to move things, to rotate them, scale them, etc. We'll see them as we need them. And at the bottom panel as well gives you access to more interfaces. And we'll see if I'm not sure we'll need one in this session, but there we go. Last thing to be wary of is when you select different nodes, you can see that sometimes something appears in the interface. Like when you select a tile map, you're going to have a special interface for level drawing where you can choose if you're going to draw plants, the background, etc. Okay, so that's for a really quick tool. Now, yeah, someone's asking if you're completely new, and yes, you are.
Yeah.
All right. We're going to start with the player. So you're going to grab the mouse, and in the bottom left, in the file system, you can see I made a player folder for you. Right? You can double click it to expand it. No, the player folder. This one. There we go. There you have a couple of sprites, a couple of images of the player. And if you go back up, you have the player animations that I prepared for you. It's a scene. You can see that from the tscn file in this icon. You can double click it to open it in the editor.
Should I open
it? Yeah. Go ahead. So you can see now you have two tabs at the top, one for the player animation scenes and one for the game scene I showed you before. So this is how you're going to edit your game. You're going to have multiple components that you edit and create separately, and then you put them together. Those scenes that you make, you can put a copy of them, an instance of them, it's called, inside of your game. So here you have the player animations. It's just animations that I prepared for you. You have the player animations node selected. If you go to the inspector on the right and you set it to playing on, you will see the animation starts to play. Then you can change the animation here in the drop-down menu and pick the one you want. Idle does nothing.
Okay.
And fly is going to have the character flying. That's what we're going to do today. We're going to make the character fly, walk on the ground, and fall. So you can set it back to idle as a good one to start with.
Okay.
And so we're going to create a new scene in which we will use those player animations. So you're going to go in the top left to the menu scene, this one, and you're going to create a new scene. So you're presented with options to create the root node in the scene doc that you can see. You can create a 2D, 3D user interface or other node. We're going to create an other node here. So you can go ahead and do that. Click that. And then those are all the nodes in Godot. Those are all those Lego blocks I was talking about that you can use. For the character, we're going to use something called a kinematic body. You can see you have the search bar highlighted at the top, and so you can start typing to filter the nodes. So you're going to look for kinematic. There you go. You can stop there, and you have in red, you have the 3D node. While working in 2D, so we're going to use the blue nodes, and you want to double click kinematic body 2D at the bottom. Double click. There we go. That's going to be our moving player. The kinematic body is something that can move, detect collisions. When it touches a wall, it can stop. When it touches an enemy, you can, or anything else, a gem, you can collect it, those kinds of things. So you're going to rename this node.
So
yeah.
I want to ask you if now my kinematic body is in this scene.
Yeah, it's an unsafe scene, as you can see in a new tab. You can double click the kinematic body 2D in the scene dock to rename it. We're going to double, yeah. You are going to rename it to player. There you go. Right now, you can see a warning sign next to it because the kinematic body alone doesn't do anything. What it's telling you is it needs some kind of shape to detect the walls and the floor, etc. Because in games, you have the characters you see, and you have geometric shapes like squares, capsules, circles that are what the engine uses to do math, to calculate the geometry and see if things are touching, if your character should be on the floor, etc. So you're going to add a new node, and to do that, you have the plus icon in the top left of the scene dock. The little plus in the top left. There you go. And the next one is going to be a collision shape. So you can start to type collision, and collision shape 2D is the one we want. This is where we start using the inspector on the right. So with the collision shape selected, on the right, you can see it has an empty shape. It's around the top there, right? You can click that on the empty or on the arrow, and then you can choose the shape you're going to use. There are two we typically use in those kinds of games, the capsule and the rectangle. The capsule makes it so if you have a corner like that and the character walks, it's going to smoothly fall off. It's going to slide off the corners, but also when you have a slope, it's going to move a bit more smoothly at times than the rectangle. The rectangle is much more precise. That's what you would use maybe in a Mario game, in a tight platformer where you want to be really precise. In this case, we're going to use the capsule, or perhaps I could use the circle, just so the character smoothly slides against things. And you will see this will come in handy when we make it fly at the end, because we're going to make it fly. So you can pick either the capsule or the circle shape.
So this will be like transposed with my character afterwards.
Exactly. This will move with, so the way the nodes work, the 2D ones, when you move the player somewhere, and you're going to see that you can select the player here, and then you can go to the move tool. It's the 4 arrows there and at the top. And you can, in the interface, click and drag to move. It's good, the tool selected. You can see you are moving the player, but because the collision shape 2D is a child of the player, it moves with it. Same thing if you rotate the player or scale it, the children, there we go, this is the scale mode if you want to try. You can click on either axis and the shape will scale with it. Although often you don't want to do that for some technical reasons.
Okay.
I'm going to cancel all those changes. We have the collision shape. Okay. Now we need the player sprite before we set the shape of the capsule. So first you're going to go back to the arrow tool, this one, and you're going to select the player to add a new node selected in the scene. Here, it's player node. And you're going to add a new node as a child of it. Do you remember how to do that? Yeah, exactly. And you're going to look for a sprite this time.
This one or the animated?
The sprite. Ah, no, we have the animated sprite. Excuse me. That's incorrect. You can cancel.
Huh?
Escape to go out.
Okay.
And we're going to, because I prepared the player animations for you, instead, you see the player animations file in the file system. You're going to click and drag it onto the player node. This is one way onto the player node, really.
Ah, okay.
You can see it changes to a hand, and now you have an instance, a copy of the player animations inside of your scene. So we'll be able to access it from the code and to make the animations play.
So this is the sprite.
Yeah, this is multiple sprites that are put together. You can see the interface that appeared at the bottom. On the left side, you can select the various animations I prepared for you. The walk animation, the idle, etc. You can click them to see. They have different images in them. Each of these images is called a sprite, typically.
Oh, okay.
So now you want to select your collision shape again, because the collision shape 2D node in the scene. And you can see the capsule doesn't match the character, right? So we want to make it roughly so it matches the height of the character at least. One thing you can do is change the order of the nodes, because right now the capsule is behind the character. It will be easier to edit if you put it in front. So you're going to click and drag the collision shape 2D node below the player animations. And be careful when you do that. You can see the icons. When it's an X, it's not going to do anything.
Okay.
But when you click and drag, there you go. You can see the line. Yeah, exactly. That was what you needed to do. Because if you drag on top of something, it's going to make it a child of the node instead, right? So it's very flexible how you place. As I was saying, it's Lego blocks, so you can really nest them and do lots of things with them.
Okay.
Now select your collision shape.
Ah, sorry.
There we go. Now it's in front of the character. You can zoom in with the mouse wheel if you need to. And you're going to do two things. You can click and drag on the center to move the shape, right? Like that. There we go. So this goes to the top of the character. Now the thing is, this is the shape that's going to touch the floor when the character falls. So right now, if you leave it like that, the bottom is aligned not with the feet of the character, but the body. So you're going to have the feet inside the ground, right? So you want to move it down a bit.
In
The
scale
shape.
as well?
No. You just move it down.
Ah, okay.
And then you have this little points that you can use to change the size of the capsule, right? So you can click and drag to change. You can see what it does. This makes the shape larger, right? This changes the radius, and the top point makes it taller. You can click and drag. We can cancel everything, so no problem.
But this is the same as scaling, but here.
It's not the same in this case. So physics are a bit special in games. Often scaling can cause issues if it's not taken into account in the code. So you have the shape that has a certain size mathematically, and then when you scale, it's going to add a multiplier to that size. So when I select the scale tool and I change the scale like that, if I expand on the side, you can see you have a radius and a height here. But when I scale the shape, you can see these values do not change, yet my shape is changing size, right? So the scale is multiplying that, and you can find it here below at the transform, under the transform category. Speaking of which, one thing you can do here is set the position of the shape to 0, just so it's centered in the scene. So you're going to pick up the mouse, and in the inspector on the right, down to the transform category, position, there you go. You can see it has an X and a Y. You're going to click the X field, the value there. You have to click on the, and enter 0 and type enter. There we go. So that moved the shape a bit to the left. This is another way to change the position. When you use those tools in the top of the toolbar, like the move and select tool that you have, those here. Yep. When you use those and you click and drag, you can do that. You can see the value changes. So the inspector and the tools are connected. You're always changing the properties of selected nodes, right? Go ahead and cancel that. And now the shape of our character is done. We can place it in the game.
And this one, the Y?
The Y,
like that?
it's fine that it's just to align the character. You can click and drag on the value if you want with the mouse. So click and drag left and right. Now on the value here in the inspector.
Okay.
Control Z, to go back. So you can click and drag instead. So you have to keep the click pressed and you drag left and right. So I'm going to press escape to go out, and you can, on this field, you click and you drag the mouse. There you go. You can drag it more and you're going to see the thing moves slightly.
Yeah.
There you go. So that's a good way to adjust the position of the capsule. So clearly.
But here is like to put it in the grid. We wanted to do that.
Yeah, you want it to align with that
The
line
red one.
here. Basically, you want it to align with the character's feet.
Okay.
So move it up a bit. You really want the bottom here to align with the baseline. Yeah, exactly.
Okay.
All right.
So this is the ground, let's say, the Y.
This represents the ground.
Mm-hmm.
In our case, it's a helper we can use to align things with the feet of our character. You're going to save the scene by pressing Control S, or you can go to Scene, Save Scene, top menu.
Okay.
Inside the player folder. So you can see this is a typical folder navigator, and then you click Save in the bottom right.
Here is fine. This
Yeah, this is a default name, player.tscn. It's going to use the name of the first node you created.
Okay.
Okay, so we can now go back to the game tab. At the top, you have a list of scenes and the game scene. There you go. You're going to place your player inside of there. To do that, you're going to click and drag. You can directly click and drag the scene. We've seen you can click and drag it inside the scene dock, but you can also drag it inside the world. So you're going to click and drag it inside there and place it wherever you want. Yeah. You're moving.
What's flying now?
Yeah. So what's happening right now is you have the move tool selected, right?
Yeah.
And you want the arrow tool. One thing you can do so this doesn't happen is, yep, good. Select the game node.
The what? Sorry?
Game node in the scene dock. There you go. And you're going to click the little, the little lock here.
Mm-hmm.
This will make it so you can't inadvertently select it and move it from the scene. So see, now you don't have that problem. You can select the player. Just going to check the chat very quickly. Are these French people? No, I'm French and she's from?
Costa Rica. Pura vida.
I don't know if there's anyone. Maybe there'll be a Yodi or someone. There's another guy called Chakra who's from here as well. Okay, so we're going to start coding from there because we have the player. I prepared the world, so the ground has that collision information basically. Okay. So the character will stay on the ground. But right now, you have the scene set up, but it doesn't do anything because you don't have instructions yet on how you're going to move the player.
Okay.
So the way you do that is you can save your scene right now, the game scene. Yeah. And you're going to go back to the player tab.
Okay.
Yeah. And we're going to add a script to the player. It's a file that contains code that the computer will understand, and that will tell the computer what to do with that player. So you select the player node to do that. And in the top right of this Docker, you have a thing that's like a text file, a document icon with a plus. Yeah, this is the add script or attach script tool. So in this interface, I'm just going to tell you, you can choose in Godot the language that you use for the script. We're going to keep GDScript. You have a couple options, native, GDScript, etc., because developers have the choice of the language that they're going to use in Godot. Then the inherits part, we're going to skip for now. The template, you're going to select it, click it, and set it to empty. Because by default, you have a little template for people who start with Godot alone. So they know, you need to put this kind of code here and this kind of code there. If they're new to the language. Then the path, you see, it's going to save it inside the player folder as player.gd. So this is good for us. You can click the create button to jump to the script interface. Here we are in the scripting interface. I'm going to just explain the first line you have, extends kinematic body 2D. Because you are working inside a game engine, Godot, you created a kinematic body 2D node for the player. This is code that other people have made inside the game engine, right? They wrote lots of features, lots of functionality that you can use that saves you a lot of time making your games. The extends keyword in this language called GDScript makes it so the code that you are going to write will have access to everything those developers made inside Kinematic Body 2D, inside the Godot engine, right? So this is telling this player script, I want it to have access to everything from Kinematic Body 2D. It's going to extend it. It's literally going to add your code at the end of the Kinematic Body 2D code file, right?
Okay.
You can think of it like that.
It's like I'm summing up instructions or something.
Yeah, you're adding code to the Kinematic Body 2D.
Okay.
Now, there are a few things that are going to be a slight challenge in Godot that I'll explain as I go, but sometimes a bit superficially, so you can see first how it works in practice, and then we'll start to break it down. So the first thing we're going to do is make the character fall, okay? Before moving left and right, perhaps. So you're going to type here, and you're going to do a line return. No,
That's
line return is enter here.
Okay.
We want to make the character fall. So the way we're going to do this is going to, the game runs, yeah, I need to explain that. The game runs in a loop, right? So every second, the engine calculates images that it displays on the screen. It's like traditional animators, if you've seen how they draw, they make lots of drawings and then they flip them, right? They show all the pages very quickly and you see things moving. A game is like that. The computer calculates many images per second and displays them one after the other. So the instructions that you're going to write, typically, the ones that we're going to do right now, are going to be inside a loop. The computer is going to 60 times per second read the code that you do and go back to the top. Once per, we call that frame, it's going to read all the code, execute all the instructions, and then wait. And a couple milliseconds later, it's going to do that again, typically 60 times per second, right?
It's not 1 frame per second.
No, it's 60 frames per second.
Okay.
Default. So to make our character fall 60 times per second, we're going to move it down a little bit. And we're going to use what you learned in physics in middle to high school, the Newtonian physics. We're going to apply a bit of gravity to the character 60 times per second. Okay. So the first thing we're going to do is create that function that allows us to tell the engine, this is what you need to do every frame, those 60 times per second.
Okay.
To define a function, you start with the func keyword, F-U-N-C. There you go. A space followed by the name of the function. I just need to do one thing I forgot in preparation for that, because we're not going to use type hints today. This is something, okay. Otherwise, it's going to add information that we don't want just yet. So these functions are special in the functions to update in the game loop are special in every game engine. In Godot, it's underscore. It starts with an underscore. So shift, no, it's shift. And here you can see the underscore there.
Okay.
Right. And it's called physics process. So you start typing physics and you can see it appear and you can press enter to accept the suggestion from the engine. Then a line return, and now you are inside the function. This language, there's something particular with the syntax. I'm going to write pass temporarily here, just so we don't get the red line. You can see it has these symbols here. Those are tabs. This is the tab key. You can see every time I press tab, it inserts one of these symbols, right? And this language works like that. The computer knows what is part of your function thanks to those tabs. We call them indentations. So the instructions, you can't write them there on the left. You have to indent them. You have to have one tab on the left. Okay. The Kinematic Body 2D node, to move things, has a special function. It's called move and slide. So you can call it in Godot. You can use the code that those developers made and have it run 60 times per second. So you're going to type move and you're going to see it appear. Go ahead. and you want to take move and slide, the second one. So you can see there are a couple of things, move local x, etc. Those are all the functions, all the code that the Godot developers wrote for you.
They are amazing.
Yeah, every game engine is like that. Now, move and slide, you can see you get this line that tells you the arguments, so the parameters, the values you can pass to the function. I just had to spit it on the screen. So a velocity, to show you, I'll take this. So excuse me in the chat, sometimes I need to draw things for Estefania, and I'm going to do this here because of the setup we have. So a velocity is going to be a vector. You remember what vectors are from math?
Yeah, I think so.
Okay, so just as a reminder, a vector is, if you can think of it as a set of two coordinates, is going to, typically we write it like that, Vx, Vy. The vector's x component, this is this horizontal part, and the vector's y component, this is this vertical part here. So you have two coordinates. You saw earlier, if I select the player node and go back to the interface and expand the transform tab here, category, you have a position and you can see an x and a y. This is a vector with two components, x and y. A velocity is a similar vector, okay? And the information gives you here are both a direction and some speed encoded together into a single vector. We typically.
But the vector is this, or was it the line?
This is a representation. It's the whole thing. So this is a starting point of the vector, if you want. This is the direction that you can see, like the orientation, and it has a certain length. That's the definition of a vector, right? So it can be in any direction, and we control that.
This x and y is the coordinates of the starting point.
No, those are the coordinates of the whole vector. If you want, on the computer, the way we represent vectors, the starting point and then the length and the end of the vector are with two sets of coordinates. We have an x and y for the starting point, and we're going to have the components of the vector as two values, x and y, right? Okay. All right, so the velocity is going to be something like that. What I want to point out is we're going to use this x and y, right, to define how long the vector is and how it is oriented, right? In the case of games, there's something a bit special. So in math, you saw something like that. You saw graphs like those where the x-axis goes to the right and the y-axis goes up, okay? In games, it doesn't work like that. It's the opposite for the y-axis. The y-axis goes down and the x-axis goes up. Those things are just conventions. So in math, you can do that as well. Actually, the axes can go anywhere you want. They can be rotated and those kinds of things. But it's just in games, it's a convention. We start counting the pixels here, the positions, from the top left of the screen to the right, and the top left of the screen down towards the bottom. So this is the position 0, 0, 0 on the x-axis, 0 on the y-axis. And this would be a higher value on the x and on the y. Okay.
So here in math, this was minus y.
Yeah, this was minus y.
So it becomes minus y here.
Minus y is to the top, yeah. Okay, with that, we can get started. So we're going to give it a vector that represents how our character should move every frame. The way you create a vector is using a name, there again, defined by the Godot developers, called vector2. It starts with a capital letter. So you're going to start typing vector.
With capital.
Capital V. Vec, and you can see vector2, you can press enter. Okay, you're going to open parentheses.
Open what, sorry?
Parentheses, next to vector2. Wait, you need to be right after vector2. Okay, and then you can see the vector2 takes an x and a y value. So for the x, you're going
That's
to...
why it's 2 or no?
Hmm?
That's why it's called
Exactly.
vector 2.
Vector 3 takes 3, x, y, z. And in math, you can have vectors of any size. You could have vector 4, x, y, z time, for example. Right? Those things are arbitrary, but they are handy to represent coordinates. This is going to be the velocity. So we want to apply gravity to our character. So we want the vector to point down. How do you think, considering that x is the horizontal and y is the vertical, how do you think we make it point down? Which values do we use for x and y?
Well, for y, something positive.
Yeah. And for x?
For x, it doesn't matter, I guess.
It does. If you make a big x, it's going to do this, or a negative x is going to do this.
Okay, 0.
Okay. So you can enter 0, comma, and then the value you want can be a few hundred, because it's going to be a speed in pixels per second, right?
Okay.
Very good. So I just want to take a second to go over the syntax here. You can see that you wrote the name vector2, and then inside parentheses, the x, a comma, and the y.
There's a space.
You don't have to put the space, it's just for readability to separate them.
Okay.
So vector2 is, let's put it like that for now. It's a built-in feature that takes values, arguments to build the actual vector2, right? Inside the parentheses it's like a function that you're going to call on the vector2 that's going to create it. And it tells you needed an x and a y. The values inside the functions need to be separated by a comma. Now, if I cut this inside the parentheses, and I open the parents there, you can see there you have something similar, like move and slide takes a linear velocity, it's a vector2. And then you have a comma, it takes an up direction, that's a vector2, etc. Right? So we're going to do the same. Our first value is the whole vector2 with the x and y. So I paste it in there, and we have the first value. Then we can add a comma, and you can define the up direction. This is important for the engine to know how the game world is turned, right? The up direction says this is up. So if you say up is like that, right? It will know the floor is in that direction, the walls are in those directions, left and right, and the ceiling is up, right? This is how the engine gets that information. Because in games, you've probably seen games where the gravity is reversed and you can walk on the ceiling and jump like that down. You've seen that already?
Yeah.
In Mario and all, I think they've done it. That's with this kind of information that they do that.
So if I put up direction down, would it float?
It won't float directly. It's just about detecting where the floor is, where the walls are, right? So if it will fall because you're moving the character down still, but then when it touches what you consider the floor, if you reverse the up direction, it would say, oh, I hit the ceiling, right?
Okay, yeah.
Okay, so for the direction, you can see it says the up direction is a vector2 as well. So you're going to enter vector2 again.
Do I need another parenthesis?
No, first you type the vector2,
Okay.
and then the parentheses is to build it. Okay, enter, no, vector2.
Oh, sorry.
A 2. You can just correct and put a 2. Open the parentheses to create it. And then the x, the up direction we want is a vector that points up like that, right? So how do we do this one? If this one was 0, 1 or 0 something, what is this one?
0, negative something.
Yeah, and negative 1, because for directions, we use vectors of length 1. So I'm going to type that. And yeah, you remember the comma, that's good. And -1, exactly. Okay, so with that, your character is going to fall. I'm going to go back to the game scene and to the 2D main screen. Select the player and move it up really quickly. And then we can play the game by pressing this play button or press F5. And the character falls. It falls very fast, so I'm going to put it up So you can see it fall, boom,
yeah.
until it touches the ground, and you can see Godot makes it stick to the ground, right? So this is the first thing you've done. Now, we're going to go back to the script, and I want to introduce a few things. You can see this works, right? But we have a little issue right there. It's that if you go back later, 2 months later, and you read the code, and maybe you wouldn't remember why is this 0,500 or what is this thing that's 0 minus 1, right? It doesn't, when we create the function, when we write it like that, when I do move and slide, it tells us it's the linear velocity and the up direction. But now we don't have the names anymore, so you come back later and you don't remember why you had that, right? And you have to figure it out. Now, there's something you have in every programming language called variables that allow you to give a name to things, right? So this, instead of being a vector to 0, 1, could be up direction. The way we do that, we can do that in different places, but we're going to do it outside the function. And we're going to do that by defining variables. To define a variable, you type the var keyword, V-A-R. You start with that. There we go, a space. And then you type the name of the variable. It needs to be letters and underscores. So typically we write a word, underscore another word. You can't use spaces in there.
Okay.
So the first one you can create would be, you can start by the word, right? But instead of spaces between the words, you're going to use a direction.
Okay.
So this is called a linear velocity. We can shorten it to velocity. So you can say var velocity. You can type the name, a space.
So I use underscore instead?
No. You're going to put a space, literally. Right? That's the whole name. Then you're going to use the equal sign to tell the language, to this name, I want to associate this value. So equals.
Okay. Oh, sorry.
The equal sign is here.
Okay. I'm used to the Spanish keyword.
Yeah. And you're going to put in the value. So one thing you can do is with the mouse, you select your first vector to here completely, and you're going to cut it and paste it after the equal sign.
Cut it or copy?
Cut.
Cut?
Yeah. You took one more parenthesis, but just...
okay.
Yeah, just the vector 2 with the values.
And I cut?
Yeah, and paste it there. Okay, great. So now you have variable named velocity. Before the comma in the move and slide function call, you're going to enter the word velocity. And you can see you can complete with enter, press enter. There you go. By the way,
now each time I want to use that, I can use velocity now.
Exactly. So one thing I want to mention is, you see when you type that, I've seen you use the arrows several times. It automatically selects the first thing, and you only use the arrows to go down the menu for another entry, and you can press enter.
Yeah, it goes automatically to the first option.
So now we have that second value that is corresponds to our up direction. How would you go about replacing it with the name up direction instead of using the hard-coded vector 2 0 minus 1? What can you do?
So I would put another variable and name it direction, and cut and paste as well.
Exactly.
So I try it?
Yeah, you can go ahead and do that.
Okay. Okay. Then I put direction, I guess.
Yeah. Exactly.
And this?
And there's a back. Well, yeah, you need to remove that.
Okay.
Okay. So there we go. The name could be, because we're going to have another direction for when the character moves, so that would be good to name it up direction. So before direction, you can type up underscore. See, that's how we name variables, and same thing there. There you go. You can play your game again by pressing F5.
And sorry, I want to ask you,
ahead.
Why did we use move and slide for falling?
Because Godot takes care of a couple things for us. So if you don't do that, if you try to move your character manually in the game, the way it works is, imagine this is the floor and your character is here. When your character moves, it can move past the end of the floor.
Okay.
So the move and slide function takes care of putting it back on the floor and many other things. If the floor is like that, it will find where to place it. You can move along the floor and those kinds of things. It's called move and slide because if you're hitting something that is not straight, you're going to slide against it. Right?
Okay.
You will see that probably a bit later. But so we use that because doing it manually is many more lines of code. And because when developers are the people made good code for you to use, as developers, we typically use it to save time. Right?
Okay.
So you can, any other questions?
Thanks.
Okay. You can press F5 to play the game. And nothing changed, right? It still works. That's a good sign when things work. You can press F8 to stop the game. There we go. Well, back to the code. So this was just show you how we name things in code to make it more readable, right?
Okay.
Now, inside your physics process, we're going to start moving the character left.
And I want to ask you
yeah.
if we left here a space for readability or it is...
Yeah, typically, so what we do in general is the functions, we separate them when we finish a function with a couple lines. Variables, we will group them. So typically you wouldn't have a line in there, right? And it's up to you how many lines you want. Typically we put 2 lines, one line between the variables and the first function.
But if I didn't have these spaces, it would work as well.
Yeah, you just need to have each instruction on its line, right? You can't put 2 variables like var velocity and var up direction. It won't work. You can try to do this and that will give you an error. Okay, the next thing we want to do is move the character left and right.
Okay.
So in the physics process, before we call move and slide, we're going to calculate a move direction and move left and right, depending on the keys you press on your keyboard.
Okay, I'll save this.
Yeah, it's good to save it. When you play the game, it saves your code, by the way. So before move and slide, we're going to add that. And so those variables we created, we can also create them inside of functions. The way it works exactly is the name, if you put it up there, is available in the entire script file, in all the functions, anywhere. But if you put it inside the function ends after move and slide. The variable, the name, will only be available until the end of the function. So inside the function, right? So typically we call that the locality of variables. We call those local variables. Those are variables, regular ones. Let's say member variables, to be precise. And we're going to use a local one because we only need to access the direction inside physics process, right?
But I have a question. So move and slide is a function that is inside the function of physics process.
The move and slide function is a function you call. It's something that exists in the Godot engine that you call inside your physics process. Physics process tells Godot, run this code 60 times per second.
I see.
So you're going to create a new variable called direction.
Here in physics process?
Yeah, on this line. First, you need the var keyword to create the variable.
Okay.
Always. Var says I define a variable. And you're going to set it equal to. And the direction is going to be a vector 2. So our velocity is a vector 2. The direction is going to be the same thing, just like the up direction, 2D vector that represents how the character orients, how it's going to move. And you're going to create a new vector 2. Parentheses, and you're going to initialize it to 0, 0. The comma and 0, exactly. So at first, we have no direction. Now we're going to listen to the player's input. Those computer programs, when you type your keyboard or things like these, the computer is constantly polling. It's asking the keyboard which keys are pressed or any other peripheral, are we moving the mouse, etc. Very often, if you want. So in games, it's the same. We have to listen to when the player presses a key using a line of code, right? And in Godot, you're going to go to do a line return of enter, And we are going to do two things at once here. First, we need a condition. If the player is pressing a key, a specific key, then we change the direction, okay? So to start that condition, you type the if keyword. I'll let you do that. Okay, a space. And then comes the condition. So this is going to be something built into Godot. This is how you ask for the keys that are pressed. So this is input with a capital I. There we go. And then a dot. And the function on the input object is called isActionPressed. So is underscore.
Just pressed?
No, action pressed.
Okay.
This one. Press enter. And then it gives you a list of actions that you can pick from. The move ones, which we are going to use, are ones I prepared for you for this first lesson. So we're going to check for move right first. You can go down, press enter. There we go. And at the end of the line, just like at the end of the function definition, you have a colon. At the end of a condition, you need to put a colon.
Colon.
Yeah.
Okay.
The colon is this one. So shift this. There you go.
Mm-hmm.
And line return.
And it finishes with the colon.
Yeah, this ends the condition. To be exact,
okay.
what the colon says is after that starts a new block that is indented. You're going to see when you press enter, it's going to go one step further to the right. So press enter. There you go. So you have another indentation level, and this is the body of the condition. Those are the instructions that will be run only if this condition is true, right? So if the player presses the move right action, which is D on the keyboard, or
but this is, sorry, the colon is only for conditions.
It's for every block. So you can see at the end of a function definition, you have a colon. At the end of a condition, you have a colon.
But
and
in move and slide, we didn't use it.
Yeah, it's because move and slide, we want to always run it inside physics process. But the code we are going to write is only valid if the player is pressing the move right action, which is the D key on the keyboard. Okay? So if the player is pressing D on the keyboard, if the player wants to move right, we're going to change our direction. Right? So you're going to type direction.
Okay.
There we go. You can enter it. Dot X space and equal. So the equal here means I want to assign the value on the right to the thing that's on the left. The direction is a vector 2. A vector 2 has two components, X and Y. You can access them with a dot, then pressing X, typing X or Y, right, respectively. So because this is X here that we're accessing, this is a single value. And so if we're pressing move right, we need the vector to point to the right. So what value do we use on the x-axis?
1.
Exactly. You can type 1. There we go. So this is very simple. Right now, what we're going to do, I'm going to do a small thing here. I'm going to say velocity.x is equal to 500 times direction.x. I'm typing this for you just for testing because then you're going to create that code. But if we press the move right key, we're going to move to the right. And the velocity, we always set it to the direction that we have multiplied by some speed value, right? And that's going to make our vector point to the right. So now, if you play the game, if you press the D key on your keyboard, the character should move to the right. But only when you press it, you see? So this is why we have this condition. This is so the character only moves in those cases.
Okay.
All right. So I'm going to remove that because I'll have you write it later.
But how does move right knows that it's D?
It's because I defined it. I'm going to show you because it's nothing magical. In the project settings, you have all the input actions and I defined those down there. So move right corresponds to the D key, or left stick to the right on a gamepad, which I'm going to bring. I'll go get it because it's more fun to test with a gamepad.
Okay.
Now, we want to have the character move to the left as well, right? So one thing you can do is align return. Okay. You're going to go back one level, align it with the if. And so there's something called, no, you can use, we're going to stick with if. You're going to do the same thing, but for move left. You think you can do it completely?
I'll try, yeah.
Okay, I'll let you do that. I'm going to go get the gamepad and I'll be right back.
Okay. Not.
Here.
Guess it's -1, I guess.
Yeah, exactly. So now this code only changes the direction, right? It doesn't make the character move. So what you want to do is, again, a line return. Go back exactly. And this time we're going to change the x velocity. So same thing, velocity is a vector too, like the direction. So you can type velocity.x equals direction.x times some value that you want.
.x?
Yeah, multiplied by, it's the star. You can
okay.
use it like there. And can be 200, 300, 400, whatever you want. Okay, you can press F5.
Okay, and it's done now.
Yeah, because we move and slide using the velocity. So because we change the velocity, we say it's a speed multiplied by the direction. Direction can be 0, 1, or -1, depending on the conditions that are met, right? So we move and slide with the velocity. So we are changing the value of that velocity dynamically based on what the player does. And you're going to test that right now. So you can use the left joystick to move the character.
Oh, yeah.
There we go.
Okay. Now, F8.
Lots of chat, but by the way, for Rasvan, who should be here, if people have questions and all, you can, if you want to chat, you can chat as well, of course, but you can also answer their questions, although I don't see too many. Yeah, it seems people are mostly commenting, so what were you trying to change? Ah, yeah, times 10. If you change the speed, indeed, it's going, you can change it again. If you
I
want
already did it faster.
Ah, okay. Okay, and you can move in the air as well, right? While the character is falling.
Oh, okay. That's right again.
Right. So,
so this I delete.
No, you're going to keep it. The only thing is, instead of 800, like we've done for the velocity and up direction, how about we name that value, right? So at the top of the script, you can create a new variable called speed.
Here.
Yeah. So it's going to be
speed and velocity were different.
A velocity is a speed with a direction put together, right? So the speed is one thing, and the direction is one thing, which we calculate 60 times per second. Speed equals whatever you want. It's the value you put there. So
500, it's fine, or?
Yeah, it might be a bit fast, but that's fine.
300?
That's fine. And so direction times now. Exactly. Just for the people watching, if you can put a line after speed, just to give some space. Good. Now you can test it if you want. It works the same.
Perfect.
Excuse me. You can use the controller anytime. I'll just keep it, or you can put it on the side, whichever you prefer.
Okay. So now it's done.
Yeah, it's all good. So that's moving the character on the ground. Now, there's just one thing. When we put the gravity like that, I'm going to make it smaller, and you're going to see the character moves at a constant speed. But that's not a realistic or natural way to fall, right? It's very floaty, it's very unpleasant, let's say. So instead, we're going to apply gravity. Now, this is something you probably have seen in physics. It's like gravity is typically a force, and so it's going to apply constantly, and so the thing is going to start slow and fall faster until it hits something that stops it, the ground, right? So we need, instead of having a fixed value here, we need to have something that gets bigger frame after frame. So there again, it's going to start at 0. And we're going to apply some gravity every frame to increase the value. So here, I'm going to have you create a new variable called gravity.
Okay.
Yeah.
There or here?
Yeah, whichever. It's good.
Okay. Gravity.
Yeah. And it's going to be equal to some value. So this time it's not a speed, it's an acceleration downwards. So the value needs to be a bit bigger, something like 2000 should do. Why? Because it's compared to a speed, that is how many pixels you are moving per second. This is about how many speed units you are increasing per second, right? So the character, the character falls and accelerates like that downwards. We need to calculate that, of course. So inside the physics process function.
So that is done gravity.
Yeah, yeah.
Okay.
Inside the physics process function, we're going to use it. So below the velocity.x calculation, you need to return. Yeah, you need to align like that. Very good. You're going to say velocity.y. And so we're going to increase it every frame, every time that physics process runs. So to increase it, you can do equals velocity.y plus something. So velocity.y plus. No, you have to type again because you need to increase velocity.y. So velocity.y is going to be equal to itself.
Okay, I get it. .y
plus.
Can I do it like that?
Yeah. Plus. What value would you like to add to make the character fall?
Like a number or
just
the gravity.
Yeah.
Yeah.
And so if you add the gravity like that, you are going to increase by 2060 times per second the downward speed. So this is huge. Don't want that to happen. If you do it, you'll see the character is like that and is instantly on the ground. Yeah. Right. And it may even at some point go through the ground and disappear for technical reasons, because that value is increasing so much that at some point might just jump through the world because it goes so fast. Okay. So you're going to go gravity multiplied by, and this is where we introduce this. The physics process function provides you with a value called delta. This is similar to when you call move and slide, you give it a velocity and up direction. You give move and slide that. The engine gives physics process delta. Inside the engine, there is something like that, just to show you. Imagine we're in the engine code, and there's something like physics process delta. It calls it, passes it the value. Delta is a time difference between the previous frame and the current one. It's how much time has passed since the previous frame. So when you multiply something by delta, you make it time dependent instead of frame dependent. The instructions you write without delta are going to be ran every frame. Now, the thing that adds complexity to games is the computer needs to do these 60 frames per second. You've probably seen a game you played that slowed down at some point, like the game started to be slow, laggy. When that happens, a thing that can happen is if you keep the instructions without the time delta, everything slows down because the frame take more time to run, So there are fewer frames that run, so there are fewer updates. And instead of doing 60 times per second, making the character move forward, it's 3 times, right? Or 6 times, it moves 10 times slower. And you see these choppy images like that, right? By multiplying by delta, you make it so the update depends on the time that was spent between the frames. And so if the game slows down, the things will still move the same distance over time. Okay, so now if we have gravity times delta and you play the game, the character, you can see now it doesn't fall the same way as before. We're going to lower the value. It's a good one, 2000, but you can see how it accelerates until it hits the floor. Okay. Now, we have the base movement and gravity working. There's one technical thing that we're going to do is here. I'm going to do this for you and briefly explain. I'm going to say velocity is equal to move and slide. Let me explain. A function can make some changes, right? It's going to move the character. It's going to make it collide with the floor. And then at the end, it can return a value. You've seen that in math, f of x is equal to 2x plus y, something like that, right? If you remember those kinds of things. When you call x, you get another value returned. Move and slide moves your character. And when it hits the ground or something like that, it says, I hit something. So I was accelerating downwards and velocity.y is getting bigger and bigger and bigger. And move and slide will say, if I hit the floor, I'm going to reset that velocity to 0, right? And so it gives you the result. It says, I hit the floor, so the horizontal velocity is fine, but because I hit the floor, the character stops. It doesn't have any more speed going down, right? So it tells you now velocity is equal to 0 on the y-axis. And when it returns that value, when it gives it back to you, you have to manually capture it. You have to manually assign it with the equal sign here. So that's what we're doing. It's not too important. It's a small technical detail that we need to take care of.
But I didn't understand. I'm sorry.
Okay. Yeah, this is a bit tricky at this point because we need probably to work more on functions and how they work. Move and slide is going to move the character based on the values that you give it. At the end, it makes calculations and it's going to send you back some new value for the velocity. That's just how it works. So it depends on every function, but it's in its documentation. If we go there, you can see there's a lot of documentation. And just tells you it makes some calculations and it maybe we can read it there. Returns the linear velocity vector rotated and scaled if a slight collision occurred. This is a bit, technical speech for people who have more experience programming, but it tells you, it returns you a value, right? This value is a new velocity. It's an updated velocity based on what happened when the character moved. And so we need to assign it to our velocity here.
But I don't understand. Maybe it's why velocity equals to move and slide, which uses velocity. So
that's what I'm saying.
Okay.
When you do that, when the code runs, this will get replaced by the value returned by move and slide. So what this says is call move and slide and give me back the result. When you call a function, that's what you say in code. You say, run the code inside this function and give me back the result. So this does stuff, right? It calculates a new velocity. So maybe it's going to be something like that new velocity, just to show you. It's going to be maybe 500 if the character was moving right and it touched the floor, right? But maybe before that, before that, maybe your velocity was 500, 1500 because the character was falling and it hits the floor, and that function is going to detect that and going to reset that value to 0, but it just returns it. If you remove that part and you don't store the result inside your velocity, the value gets lost. It makes a calculation. It says, here's the value. Nobody uses it. I don't care. Right? So you store the result in the velocity variable. There we go. And And with that, you have your character falling, moving left and right. You
Okay.
can test that in the game if you'd like. You have the controller.
Mm-hmm. Okay.
All right. The next thing we're going to do, if you want, are the gems. So we're going to collect gems. Okay. I'm going to remove the distraction-free mode and go back to the 2D workspace. Right. Let's move your player somewhere like that. So now we're going to create gems that when we touch them, we can collect them.
Mm-hmm.
This needs two components. We need to design the gems to be collectible.
Okay.
And then you will need to add some code to collect them.
Mm-hmm.
Okay. For the gem, we're going to create a new scene. Do you remember how do you create one?
Let me try. Here.
Okay. In that scene, you're going to create an other node as well to start with in the scene doc. Yeah, that works. And the one we're going to...
Okay.
No, it's good, it's good.
Mm-hmm.
Yeah, it's the same.
Mm-hmm.
The node that you are going to create right now is called Area 2D. There you go.
Okay.
So this node defines an area. The kinematic body is going to hit things and stop on the floor, etc. The area is not like that. You can use it for any kind of area, like inside water, you change how the game works, all those kinds of things. So it's just going to be, it's going to use a collision shape like we use for the player. It can be a circle, it can be a capsule, it can be whatever. But in itself, you can pass through it. It's just going to detect that you touch it and tell you, right? So as a child of the area, you need to add two things. First, we're going to add the gem. So in the file system in the bottom left, you can fold the player directory. And then you have maybe the red jewel, right? And you can click and drag it inside your scene.
Here?
Yeah, and it creates a sprite node for you. Now it's a bit far off compared to the start. The one thing you can do is select the red jewel node and you can select it in the... No, now you're moving everything.
Sorry.
Select the area 2D.
Should I return it?
Yeah, Control Z. One thing is, by the way, no, no. You've canceled a bit too much. Well, you have to recreate the area 2D node. No, you have to recreate it. Area 2D. And then you're going to click and drag the red jewel in the scene.
Wherever.
Yeah, we're going to move it. So I'm just going to mouse wheel, click and drag to move the view and center it here. So and zoom in so we can see our jewel a bit better.
Okay.
Right. And so what you're going to do now, the jewel, you want to roughly center it on those axes, right? Because otherwise it will be offset every time you will place it. It will be offset. The problem is now you're selecting the area. So Control Z. This is the move tool, and you need the select tool, which is the arrow. There you go. And then you can click and drag it and place it in the center. Great. Perfect. Select the area again. You can see the warning sign. It tells us we need a shape like we did for the player, right? So you're going to add a new collision shape 2D node as a child of it.
So let's say the image without that is like...
It's just an image.
It's just like...
Yeah, it just displays on the screen. It doesn't do anything. You can't detect anything from it.
I see. So I have to
add a node. Yeah. Collision shape 2D.
Okay. And I do the same. Put it here.
No, you can keep it down. It's fine. Now the collision shape has a warning because it needs the shape. So select the node. And in the... Yeah, you remember the shape. You need to click. And you can create a circle for this one. There we go. You can click and drag. This is the area that will control when you touch this circle with your player's capsule, you will be able to collect the gem. So you want to make it roughly the size of the gem. Now you're moving it, and if you click the point, you have to click that little point if you want to change the size. There we go, that's perfect. You can save that, right, as maybe cancel, and you want to rename area 2D. At the top, double click to gem, for example.
Gem, jewel.
Jewel, whichever you prefer. Yeah, press enter, save. You can save Control S, and now it's going to save as jewel.tscn, which is the scene file. Okay, you're going to add a script to this jewel as well. And you remember how to do that? Top right of the scene doc. No.
Okay, let me see here.
No.
Here.
No, this creates a new scene. No, you need to add a script. It's right there.
Yeah.
And you can create it straight away. Click the create button.
This is fun.
Yeah. Going to use the same language and everything.
Okay.
So this one you can see it's different from the player was a kinematic body 2D node. Automatically we get the extends kinematic body 2D line. This time it's extends area 2D, which is a different. It has different features compared to the kinematic body. This time, how are we going to do this? Okay, that I can introduce a feature that's a bit special. So we saw with physics process that we can write code that Godot will run 60 times per second. Now, with the area, we could do that. We could use physics process and 60 times per second ask, is the player touching me? Is the player, nearby, right? And if that's the case, we do something. There's another feature in Godot and in programming languages often to make it faster, because running the code 60 times per second, well, it's often more work than you need to do. Often you don't want, if it's something that happens just when you touch the area, you're like, why run it 60 times per second if instead I could just do it once when I touch it, right? You can do that in Godot through a feature called signals. Signals are inside the engine. The engine does its stuff. It does its physics checks. And then it tells you this happened, right? I did my calculations. This happened. So in the case of an area, you can know when something touched it through a signal. For the signals, I'm going to show you to set them, to connect them to, by default, they're all disconnected. So you don't receive any information, and you have to selectively connect the ones you want to listen to. This is for performance, because listening to lots of things you don't use is a waste of time. So in this case, to find,
I guess it helps with performance.
Yeah. On the area node, to find the signals, we go to the node tab, and then you have the signals here. And you see you have a long list, and you can see why they are not all connected by default, because there are many of them, right? And then on the area 2D, we can see a couple that are interesting. Area entered means another area intersected with this one, right? But our player is a kinematic body node, so you want to use the body entered here. Okay, so I'm going to go back, and just to so you know, to connect a signal, you double click it, then you select the node you want to connect it to, which has to be a node with a script, and it's going to create a function for you. I'll explain that later, but first we're going to go back, and you need to do that yourself. Select the node, go to the node doc.
The node?
The jewel node, the area 2D, which is, just this one. No, just the jewel.
Just the jewel?
Yeah, you're not selecting it right now. The top jewel node. This one. Click.
Okay. This one.
Then you go to the node tab, and you double click the body entered signal to connect it. You're going to connect it to the jewel.
This method is fine?
Yeah.
Okay.
A method is a function. It's technical term for function that is attached to an object, to something like a node, if you want, in this case. Right? So you can see it created a function. You have a little icon that you can click. It says the jewel connects the body entered signal to itself, right? This is what this means, because you can connect to other nodes as well. Okay, you can click OK in there. And so when the body entered the jewel, that body is going to be our player because there's only that in our game. You can write some code. So you can replace the pass instruction. Pass just means do nothing, but don't give me an error, right? So I'm going to select that line and replace it entirely.
Okay.
Go ahead. And we're going to call a new function called q_free. So q, and you can press enter. There you go. Q free means delete me. The term Q is because, again, technical thing. It's like sometimes there's a little delay for the computer, so it might be nanoseconds, right? So, but it's just technical because you have the other free that is unsafe, and Q free is safe. Okay, but we use Q free in Godot almost all the time. So there you go. You have that, and that's enough to just make the jewels disappear when you touch them. So you can save now. Then you go back to your game scene.
It's fine, it's empty.
Yeah.
Oh.
Q free doesn't take any argument, it just says delete me.
Delete me
is the jewel. No, it's the jewel and the children that go with it. The way this works in this kind of code is when, like before you called move and slide, you didn't say move and slide me. Automatically, it's implied that is the player which has the script attached to it. So when you call Q free, it's the same thing. It is implied that this is a jewel that has a script attached. Okay.
That's why it's extends area 2D, because we are working on it. I get it.
So now you're going to go back to the game tab, the game scene, sorry. There you go. And to the 2D main screen, which you can see at the top.
This is
2D.
Fine.
Yeah. The script view is different from the scene view. So you have your player in your game. Now you're going to add some gems. So click on the game node first.
On the
game node, this one, because when you drag and drop gems in the view, they will be added as a child of the selected node, so as a child of the game. If you drag and drop them and you have the player selected, it will be a child of the player, and so when you move the player, it will move the gem. You can do that if you want. Select the player. Select it. There you go. Then you need to find in the file system the jewel scene, so jewel.tscn. You can use search file to find it. So type jewel, and you can see jewel.tscn.
But finds here.
Yeah. It's just for fun. Jewel.tscn. It's a file. You can drag and drop it. There you go. You can drag another one. Jewel.tscn. No. This is just an image. There you go. Wherever you want. And now play the game. When you move the character, what happens?
Sorry.
Because the jewel is a child of the player, when the player moves, the jewel stays at the same offset.
It's like the game we played the other day.
Which one? Pikuniku?
No. The
which one?
Also one? I forgot.
Baba Is You. Yeah. Yeah, great game. So now with the game node selected, you can do the same. You can drag and drop jewels inside your game. Go ahead. I'll let you do that. So jewel.tscn, that file, right?
So I put them
wherever you want. Wherever the player can reach for now, perhaps, because if you put it in the sky, you won't be able to collect them. No.
Sorry.
TSCN.
Yeah.
No. Not dragging the image again. There you go. So now you have 3 here. One thing we're going to do, I'll do it real quick, is just remove that stuff so you can see them better. Now you can play the game.
I want to see if it has.
Yeah, it will work like that. So you can see you touch the jewel very fast, and when you move forward and you touch them, you collect them.
It's nice.
So technically, they're just getting deleted. We don't have code that keeps count of...
Absorbs it.
Yeah, exactly.
Yeah.
But that's a start already. Adding the collecting and the accounting for that would take a bit more time. Let me see, how long have we been? Yeah, it's been 1 hour 20.
Okay.
So...
I want to ask you if we can reduce the velocity to see when it collects this one.
Yes. So how do you think you would do that? Where did we define the player velocity?
Let me see.
Player animations, you can close it already.
This one?
Yeah.
It was in the script here.
Yeah. No, this removes the script.
Oh, no.
You need to click the script icon. It doesn't delete it. It just says detach it. There we go. Where is your velocity now?
Here in gravity?
Yeah. Okay. And probably you need to go back to the game scene.
Oh, okay.
You need to go back to the game scene. Click the 2D screen. There we go. And you need to either move the character up a bit or the jewel down a bit, because otherwise it's going to be too fast.
Yeah.
So it works. You can see.
Okay.
All right. Next thing we're going to do is perhaps animate the player. Right. I don't know if we'll have time for the fly thing or we'll need to go very fast.
Okay.
Your call. Because the fly thing is cool, but it involves more math. So to explain the math is a bit longer.
Okay.
We're going to add the animations on the player. Now, this is going to introduce something new. We have a player node. We have a player animations. When nodes are as children of one, you can access them from your code, and you can say, do something with this, right? So I'm going to show you very quickly, and then you're going to reproduce that. One thing we can do is we can say, if direction.x is not equal to 0, we can call a function called getNode, and we're going to get a node by name, player animations. And once we get the node, we can put a dot, and we're going to play or animation is equal to walk. We can set an animation by name like that. I think that's the way we do this. Animation, yeah, that's the property. Okay. And we're going to set it to playing and idle by default.
It didn't have the animation, right?
No. So that's the thing. So you can see there, not animating. But if I press, now it animates. But if I stop, it doesn't stop. So this is just to show you, I wanted to introduce that to say the computer does exactly what you tell it to do and nothing more. So if I say, if the direction is not equal to 0, set the animation to walk, but I don't tell it to set it back to idle, then it's just going to walk indefinitely, right? So I'm going to have you write that again. If the direction is not 0, you use exclamation mark equals to say not equals. But if direction, good, dot x is not equal, so it's exclamation mark equals. Exclamation is shift here. Equals?
Not equal to 0.
Yeah. Colon. This is a condition, so this is the end of our condition. Okay. Then you go down one line, and you can say, we have a function to get access to the node. We need to be explicit. Remember, we need to tell the computer everything. So you say, get the node, player animation. So get underscore node. Player animations. So you can go, no, you need, because it needs to be, it's not that, it needs to be in quotes. So it's easiest to use that. You see there are quote signs.
Okay.
We say it in quotes because when you see the quotes like that in yellow, it means the computer is working with text information, right? So there are lots of things in the computer that we do with text, just like the actions, is action pressed, move right was the textual representation, textual name for the action. So you get the node player animations, dot, you're going to access the dot. By the way, I didn't mention it. No, after.
Okay.
We'll first get the node, and then it's going to give us the node. See, when I say the functions return something, when you call get node, when the code runs, this is replaced by the actual node player animations, right? So it's like if you had the node and you write the dot to say access something on this node, on the player animations node. you're going to type, it has a variable like the ones you made above called animation. There we go, you can press enter, and equals. And there again, as text, you need to give it the name of the animation. So you need to add quotes, which is shift here. There we go. And now you're typing inside the, exactly, the name is walk. Yeah. The names are exactly the ones I define here. Idle, walk, and fly are the three animations we have. And you'll see that inside the Godot editor, I set the animation to be playing. I check the box here.
If it's off, it wouldn't work.
It would just not play. It would change the animation, but it would not be playing. Right? Which can seem a little weird, but again, you need to tell the computer everything. And sometimes you want to change the animation before playing it in preparation, all those kinds of things. So if the direction is not equal to 0, the character walks. Now we're going to introduce another thing.
Can we move a bit this to see? Like
yeah, we can actually do this, giving you a bit more space. Then it will do the same thing I showed you. So we need to change it back when the direction is not 0.
So
when the direction is 0, sorry. The way we do that, you could use an if direction is equal to 0, but there's a keyword called else, right?
Oh, okay.
So you can type else colon. Yeah, because there are so many cases in programming where if this happened, do this, else do that. It's so common that in every language, pretty much you have that.
Okay.
So you can go to the next line, and it's going to be the same. Get node player animations. Just a little thing, you can save some time instead of typing everything. You want to type everything, or for practice, or?
Yeah, but
okay, go ahead. No, go ahead. We can duplicate lines and move them around. So.
And then player animation as well.
Use the arrows, press enter. Yeah, exactly. Then to access the animation variable.
Animation equals to idle, I guess.
Exactly. It's pretty good, right? Like, are people saying, well, they're just chatting. 10,000 persons came on the screen. I didn't see if there was someone from family or something, probably, but... and
then we can try it, I guess.
Then you can try it, exactly. So,
but
if you keep walking, it's going to walk, right? And if you stop, it's going to stop and go back pacing towards you.
Okay, yeah. Cool.
And one thing we can do, you saw that if you walk to the left, it still looks towards the right?
Yeah, I think so. Let's see.
Okay, we can make it look towards the left.
That's why it was like weird. Okay.
Yeah. So the way we make it look left is when we change the direction, we're going to change a property called flip H, right? So if I'm going to play the walk in the editor, just so you know, everything we're editing here, when you change the animation in the code or you change it here in the editor, you're doing the same thing, right? You're changing the properties of the node. This is just a visual representation of what your code is, basically.
Okay.
So you see the character looks towards the right. If we turn on the flip H, it's going to look left. So we can change flip H.
Flip V would be like upside down.
Exactly. Like that. Which you can use to make weird things. Okay, so flip H, if I show you here, in Godot, in the inspector, as I'm telling you, this is the variables available on the player animations node. Like the variables velocity and all that you created. Now, they are presented with nice capital letters, but inside the code, you can see property is flip underscore H, right?
Okay.
So you will have to type flip underscore H to change it. And then this is a checkbox. This is a particular type. This is a particular kind of values called booleans. There are two possibilities for that. When it's on, it corresponds to the word true. When it's off, it corresponds to the word false, right? So boolean can be only true or false. Can't be a number, 1, 2, 3, 4, those kinds of things.
Okay.
So back to your code. Now what we're going to do is when we move to the left, we're going to flip the character. When we move to the right, we're going to unflip the character. So you can start with the left. Perhaps you add a new line inside the condition like that, and you're
inside.
Yeah, inside. Otherwise, it's always going to run, right? And then you can do the same. Get the node player animation.
Okay, like the one before.
Get underscore node. Player animations. And then after the parentheses, a dot. Flip. I'm going to see flip H. Equals. I told you true is going to flip the character. False is going to not flip it. So what do you use here when moving left?
This is true.
Yeah. Okay. Now you can duplicate the line with Control D. Control D, the shortcut.
Okay. Control D.
Yeah. And then you can move it with Alt up and down. Like that. So Alt up a couple. You keep Alt press and you exactly. So now when you're moving right,
false.
You set it to false.
But is this necessary?
Yeah. Because once you set it to true, told you the computer does exactly what you do. So it's going to make it look left. And then it doesn't do anything else. It keeps it moving left. See? Yeah. You don't have to delete. You can press Control K for comment. So this is
what?
Okay.
It's like omitting for a while.
Exactly. A comment starts with the hash sign here. You can see the line becomes gray. Godot will just ignore it when it's like that.
Okay.
Now, you can comment it and you can try the game.
I see. Okay, yeah. Then try it. Oh yeah. It works.
Yeah. So now you have the animation working. Let's see what time it is. We have about 30 minutes, I think. So, well, we can keep going for a long time. I just need water because I'm going to die. What can I give you to do now? In the meantime, one thing we can do, if you want, I'll just show you that while I go get... When you select the ground here, you can draw things. So you can click and drag, and you can draw the ground here. You can select the water and draw water. So just to show you, the water is in two parts. The ground has this magical feature that allows you to automatically form platforms like that. It's called auto tiling. The squares I place are called tiles. And auto tiling means, based on some rules, change the look of each cell, right? And click left to draw, right click to erase, and you can select things like those. So typically you will draw some ground, and you can place some fences above, some signs which you can pick like that, or some plants.
Are you going to make it play?
Yeah, we can do that afterwards. Okay. We'll go a bit quickly over that.
How can I move if I want to move?
Middle click and mouse. Middle mouse click, sorry, and drag. And another thing you can do, I'm going to expand the view, and you can click output here to fold that. Click. Okay, and middle mouse click and drag to move the view. And it's infinite. You can draw.
Where are the things?
Which things? Background. You select here. This is your palette. Yeah, and you can click and drag.
And if I wanted to like the background yellow?
The background, you don't have to worry about it. It's going to move with the view.
Oh, okay.
Right. So the background is always going to fill the entire back of the screen.
And how do I delete?
Right click.
Ah, okay.
I'll let you do that. I'm gonna get some water. Do you want something?
No, thanks.
I'll be right back.
Okay.
take some. You don't want cashews or something?
No, thanks.
Having fun?
I'm just adding things like that.
You can Control Shift, click and drag to make rectangles.
How? Click and drag?
Control like this. Let me show you. Okay. Control Shift. You can see I hold them. Click and drag, and it makes a rectangle.
Control Shift.
Control Shift, click and drag.
Okay.
And you can.
Yeah, I didn't know that.
Yeah. And then we're going to pass to the code. Let's see. Some nice stuff. People are mostly chatting. Not too many questions.
Okay.
Pretty good. Yeah, it's pretty crazy. There's been almost up to 250% at some point. All right.
Okay.
You're good?
I'm good. Yeah, I think so.
Okay. So now we do the flying things to wrap things up. Okay. I'm going to remove the expanded view, and what we're going to do is just have, well, you had some jewels there. Now I'm going to move them up there. And now to get them, well, you can't, because you can't jump or anything. So everyone, instead of teaching to jump and fall, we already have the gravity. Jump is just making the thing go up. You use the arrow to select things in the view like that. Yeah. And you can click and drag and move them as well. We decided to go with a flying mechanic. This is mostly for teaching purposes, because then you can introduce some more back to math. And for people who do a bit of math at school, it's good. Except we're going to be a bit short to explain everything. So we're going to have to go a bit fast. Delete to it. Okay. All right. You can zoom with the mouse wheel like that.
It's not a line, but it's fine.
It's fine. It's fine.
Okay.
Align Technologies. That's the company she worked at before. Okay. So in our player code, we're going to add some code to make it fly. We'll see if this works. I have no idea, but we'll try to make it work. So the way we're going to do this is, we need to change the controls when the character is flying. Okay, so this will be a bit trickier than I thought, but we're going to do that. Okay, so one thing we can do, I'm going to add a variable called fly speed. So it flies a bit faster than it walks on the ground, so 500, okay? And now we're going to have controls where it allows us, when the character is in the air, right, to fly like that, right? You can change the direction you're going. If you want to arc like that, you can, and you're going to do that with the joystick.
Okay.
Now, in games, those kinds of things work like that. You have some code that makes the character move on the ground. But now in the air, you want to change the controls a bit. So you're going to need big conditions. So we're going to complexify our code to have kind of two modes. If the character is flying, all right, it should be flying, we're going to have the flying controls. If the character is on the ground or just falling, something like that, we're going to have the ground controls. And the way we're going to toggle that is by pressing the key. So with the character, we're going to make it jump maybe with A, all right, to jump initially, and A again to fly. And then you can do this to move in the air, perhaps. We can try something like that. So there are many notions I won't have the time to explain in detail right now, but let's get that done. Perhaps this can be a bit more a mix of you code a bit and I do a bit of code as well as a demo to save some time. Because I have to figure out some things that I didn't think about in advance. So the way we're going to make the switch here.
If we don't have time, we can make it jump. Only jump.
Jump is very easy. Yeah, Don Elliot is here. Buenos dias.
I'll be right back.
Okay, go ahead. Okay, I'm going to do the demo. Our landlord is here. So, the way we're going to do that is by introducing two functions. I think that would be the easiest way to do this. We're going to have a move on ground. Okay, and then we're going to have in physics process two different conditions to manage the two different states. Right, and then we need to pass in the delta, I guess. I'm going to explain it to her when she comes back, and we're going to have another function above that, which is going to be function fly. All right. So what I did is adding two functions, right? So you can do that. You can define as many functions as you want in the code. And we have one called move on the ground, right? Okay. Well, this is, we could call it, I'm going to change it to platform movement. Platform and move. And we're going to have...
Sorry, what have you done until now?
I just took the code you had in physics process. I moved it to a new function called platform and move, right? So that will make it easier to see the change in state. If we're in this condition, we do platform and move. If we're in this other condition, we do fly, right?
Okay.
So it's like splitting physics process into two to make things more readable. You can create new functions like that with the func keyword. I define the function as taking the delta parameter as input, and we pass it when calling the function.
So basically, it's like we define platformer move is this.
Yeah. You see, when we call move and slide and we pass the velocity, etc. Well, this is how we define a function that we can call, except move and slide is inside the Godot engine, and platform and move is one we just created inside of GDScript. You can see the definition here that I'm highlighting. Okay, so we're going to have platform and move, and we're going to make the character jump initially. So inside platform and move, this is still platform and movement. The way we do that is with a new line. We're going to check if the player, I think I don't have a jump input in there, like it's called move up, but we're going to call it jump. I'll just create a jump action. With the, you can see roughly how this is done. So W key on the keyboard, and joy button, the A key on the Xbox controller. There we go. So now here, after applying our velocity, you can use a similar condition to this one. If the action pressed is jump, then we're going to change the velocity. We're going to make it point up, right? So you can go ahead and do that. If input is action press jump,
Action press jump.
Yeah, colon at the end. And then we do, we're going to give a vertical velocity. So how do we do that? We're going to make the velocity go up. How do you think we would do that?
So direction point x equals 1?
No, x is horizontal.
Oh,
and
yeah,
we need
y.
to change the
Direction
velocity.
Point y.
No, the velocity. Velocity dot y is going to be equal to
velocity dot y.
Yeah, because we want to change the vertical velocity, is equal to. And what kind of value would you use to have the character go up?
Negative -1. No.
-1 is very small. It's a velocity. It's a speed in the up direction. So what kind of value would you use to make it go up a lot? It's minus something?
Minus gravity.
You could do that. It would be a big value, but minus whatever you want.
Minus velocity dot y?
No.
Oh, that doesn't work.
The problem is if you reverse it, if the player just starts falling down, then it will just go up a bit and then it will fall down again. Right?
Okay.
You want the jump to be a fixed value in games for the player controls. So player know exactly what to expect. So what we can do is minus 800.
Okay.
And once more, we can create a new variable, and it's going to be jump strength. There you go, because it's a bit of an arbitrary value. It's immediately we set the velocity. Sorry, jump strength is going to be minus 800 because we need to move on the y-axis, and we're going to put it in there. Okay.
And now does it jump?
Yeah, but it's going to do something very interesting. I'll let you test. So you can press A to jump.
Oh, okay.
And press anytime.
Oh, no, I can actually kind of fly. And
So,
now?
Yeah, that's a way to fly. So to explain what's happening, you can jump anytime right now. We're not exactly flying. We don't have a fly code there. But I want to show you a couple of things with that. So while this is fun, this is still a bug. There are a couple of things that are happening. First, the condition says if we press this action anytime, we make the character jump. So if I were to lower the value here, and I keep the A pressed, it keeps going up. Basically, our code makes the character go up whenever we press the A button, right? So in a sense, it's kind of like flying. I didn't think of it, but it's an easy way to make the character fly. So let's say minus 500 so it doesn't jump too high. Going back down the code to where we were, we need two things. First, there's another function called isActionJustPressed that is going to say if you keep it pressed, it doesn't keep registering as true. It's just the moment you press the button until you press it again.
Okay.
Now, this introduces another problem. I can jump. See, now I can't keep down, right?
Yeah.
But I can jump as many times as I want. And that's not what we want. So we need to complete our condition. When you have a condition, you have if condition, but then you can combine multiple. You can use the and keyword to say this and that have to be both true. Or you can use the or keyword, the left or the right condition have to be either true. We need the and keyword here after the jump. So I'm going to let you put a space and space
before
the colon. Yeah, that's still a condition definition. So and
literal.
And you're going to call, there's a function on the kinematic body 2D called is_on_floor. Underscore on. There you go. And now you can play the game and you can only jump if you're on the floor. Pretty cool, right?
Yeah.
So that's your typical platformer. One thing I want to mention here, you remember how at the beginning we put the up direction? Well, the is on floor, as I told you, you need the up direction to be correct for this to work, basically. That's how you tell Godot, this is the floor's direction. It's the opposite of the up direction, right? Anyway, now this works. I'm going to do another thing. We're going to have another condition to trigger the fly mechanic. If, so...
There's an error.
No, it's okay. It's fixed already.
Okay.
It goes pretty fast as you type code. It tries to make some checks to warn you if something is incorrect. The way we're going to do this, okay, we're going to add a new variable called isFlying, and it's going to be equal to false by default. I told you it's a Boolean, it can be true or false, and we're going to change this. Now, we're going to say if the character is flying, we call the fly function. Otherwise, we call the platformer move.
The fly function is already in Godot.
No, it's in there. I wrote it earlier. And actually, I need to put the delta in here and in here. So we transfer the delta from physics process because we're splitting physics process in two, so we want the same information. Okay. Now, the character is never flying for now because it's always false. So one thing we can do is change the value of is flying based on the character state. So if the character is not flying, so you say not is flying, and not is on floor, you put the not before to negate what comes after it, right? So if it's not flying and it's not on floor and the player presses the jump again, you can put as many and as you want. Input dot is action just pressed, jump. Okay, we have these three conditions. We can say is flying equals true. So this will make our character fly. Now, flying doesn't do anything.
But I have a question.
Yeah.
What is if not is flying?
If flying is false, so you could write it like that. Actually, I wrote that. This is the way we typically write code, but equal, to check for equality is two equals, because one equal is to assign the value.
Two equals is what, sir?
Check for equality. Is flying is equal to false.
Okay.
Right, you're asking the question. We do that because the equal, single equal is already taken for assigning the value to the variable. Right. So we have, if those three conditions are true, right? If all those three are met, we're going to make the character fly. And if it's flying, it's going to call the fly function. Otherwise, it's going to do the platform move.
But I didn't understand why if it's flying, false.
Because if it's already flying, you don't necessarily want to make it fly. Well, I guess we can remove that. It's not going to be a problem, right?
No, but I think I got it. It's fine.
Yeah, if you want, it's going to start conflicting when we add the rest of the code. As well, going a bit fast. I'm adding those things. This is a safety check to avoid bugs, basically.
I see.
And otherwise, else if, this is a check. No, we can just we can stick with the ifs for now. Elif is try this condition. If it's not true, you try this one, and then you have else last, right? So, well, I can show you that. Elif is flying. So you don't need to check for equality with Boolean variables. Variables, if it's true, basically what conditions do here, when you say input, blah, 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 it's going to be replaced by true or false. And all conditions work like that, right? So not is on floor is on floor is going to say true or false, and we negate it to say the character is in the air, right?
Yeah.
So same thing, when I said not is flying might be true. So we negate it to say only if the character is not flying, right? We do that. So we can say if is flying, if the variable is flying is true, and we're going to do that, and that or the character touches the floor, I guess, or is on floor, like that, right? So when the character is flying, if it touches the floor, goes back to platformer movement. If it is flying and the player selects to stop flying by pressing the jump key, then we go back to not flying. What I'm going to say is flying is equal to false, right? And then in flying mode, so we can jump, we can keep that. And if I press A again, it's in flying mode right now. There's no flying code, so the character doesn't do anything. Now, how do I go back to normal mode? Press A again. I'm in platform movement. So there you have the code to switch between two general behaviors. We call them states typically in games, and you can press A to fall back on the ground if you'd like. The next step is going to be to write that fly function. So this one, if you don't mind, because we're getting, it's almost 2 hours, I'm going to write it for you, run you through it very quickly, and we'll close here. Okay?
Yeah.
So can we exchange chairs or?
You can move, I guess.
Okay. It's just, I don't need to be fully, but I need to be more in front of the keyboard. So this is more demo-like, right? When we fly, we're going to use a math equation to make the character move smoothly in a direction. So it's not going to move exactly where you put the stick. Instead, it's going to smoothly turn towards that. Okay, it's called the steering behavior, and this uses vector calculations to make, if the character, the player, wants to move like that, and currently it was moving like that, instead of instantly going there, it's going to do like that, right? So we use that with vector math. The way we do it is we have our two vectors, current velocity, the velocity we want, we call it the desired velocity. And there's a difference between the two. It's a vector between those 2 points here. So what we do is we calculate the difference and we add a little bit of it. So that makes every frame, because it does 60 times per second, it's going to do that, right?
Okay.
So that's what we're going to do. I'm going to create another variable called direction. Note here, the direction is local to the platform and move function. So what I'm putting here is independent from the other function. This is going to be a vector 2 and a value 0, 0. Now, we can calculate the thing like this. So direction.x is going to be equal to input.getActionStrength, like that, of move right minus getActionStrength of move left. This is a special feature that takes into account, if you just press the stick a little bit, the value is not going to be 1 like we do with the direction. Instead, it's going to calculate the amplitude of the joystick to make it so if you use less joystick like that, the character is going to move slower or turn slower, right?
Okay.
So we can do the same for direction.y. It's going to be get the action strength of move down minus move up, right? And so this is going to calculate a vector that is going to turn like that. And I need to do one last thing called normalizing the vector, because a direction is what happens is if you move right and up, so in the top right, the problem is the x component is y, the y component is -1, right? And the vector is then longer than 1, right? So it means when the player moves diagonally, if you don't normalize the vector, it's going to move faster in diagonals. I think I showed you once in the game Forager that you could do that. When you went diagonally, you could move faster because they didn't use that thing. Very often we want to do it. Normalize just says the vector, if it's longer than 1, we reduce it to 1. Or we make it so the vector is always of length 1, which is exactly what we want for directions. Okay, so we have the move direction. Now, when we are in the air, we're going to define a variable. That's the steering behavior, the equation I was talking about. So the desired velocity is equals to direction times the fly speed. So this is a bit like the direction times speed that you had here. But here it's like, this is where the player wants to move. This is what the input tells us. But we don't want to go there immediately. So we're going to do something called steering. We create a new variable. And it's desired velocity minus the current velocity, right? So if the character is going at that speed in that direction and want to go there, then it's the vector that goes from this one to this one, right? Then we're going to add to the velocity. One thing I didn't get to show you, there are many shortcuts in code. There are many things you did that you can do much with less code faster. One of the simplest ones is plus equals to add to a value. Down below, you had to do velocity.x equal velocity.y, plus gravity times delta. Well, you can change it in velocity.y plus equals gravity times delta. This is a nice shorthand. Velocity.y, velocity is we're going to add a portion of steering. So we divide it by an arbitrary value. The higher this is, the more drag, the more inertia the character will have. The lower this is, the faster the character will go, right? And so the last thing we do is called move and slide. And we're going to pass in the velocity and the up direction. Now, right, it's a bit weird because we don't have gravity applied. So one thing we can do with that is apply a little bit of gravity. I'm going to copy the line you had here. Velocity.y. Okay, I'm going to add a condition like this. If direction.y is not equal to -1, or sorry, I need to do it like this. If direction.y is not equal, is lower equal to 0. So if the character, if you are pulling the stick down right here, right? We're going to apply a portion of gravity, so gravity divided by 3. Excuse me, I'm used to using those numbers here with the point. Didn't get to work on them today, but okay. So see, it's falling a bit, so we're applying a bit of gravity, and now we can move the character like that. Last thing we can do is something pretty cool. We can get the character, and I'm going to show you get node, because we use it a lot in Godot. It has a shorthand, it's the $sign.
I'm sorry, I have a question. Why it's minus here? Like
why? What is minus?
Here, the sign, this sign.
Excuse me, that's a mistake on my end. Greater or equal to 0. You're right. Player animations dot rotation is going to be equal to velocity dot rotate angle. I think it is. There we go. So we're going to turn the sprite to look towards the velocity, and you can test this and see. You can jump. So when you're flying, you don't have, you can see. Okay, so this, let me explain what, it looks a bit weird. We agree. There you go. That's a fun bug. The reason is angles are based on conventions. So the base angle is looking to the right in Godot. An angle of 0 is like that. The same as in trigonometry with the circle, if you remember that. So an angle of 0 is looking right. But our character, the sprite, is looking up. So when we change the angle, the problem is it's offset by 90 degrees, right? So I need to offset that. And the fun thing is angles by default don't work in degrees, they work in radians, which is something. Do you remember something like that from math class? It's a circle with a cross, and we say the angles are like pi divided by 2.
Oh, yeah.
That's angles instead of degrees. Those are in radians. Those are based on the value pi. So we need to offset by pi divided by 2. Let's see if it's correct, because there we go. And now, and when it falls on the ground, so while you are in the air, I know why this is not working well. You need the game controller. So now the character will fall. Yeah, it definitely needs more gravity. So the gravity divided by 3 was unnecessary. Okay. Wow, it's because the steering is overriding that. So now you can fly, and you can go collect all those things, right? And when you fall on the ground, I just have to do one last thing, or I'm going to let you do that. Okay. When you go back to the ground, when you stop flying, we need to reset the character rotation to 0. Okay. You need to get the player animations node, dot rotation, and set it to 0, and you're going to do it here when we stop flying. You can use the $sign to get the node. It's
dollar is here.
Yeah, shift $. And this is like calling the get node function. This is just a shortcut built into the language. Okay. So you can get the player animation node, dot rotation.
How?
Equals to 0. We'll reset it. And that will make it so when you touch the ground or you stop flying, the character will.
If flying is false.
Basically, this is the condition to say we were flying, but we don't want to fly anymore. So we set flying to false, and we reset the rotation. I see. Now you can play the game with the gamepad and grab all the gems now. So you don't jump many times, right? When you press A, you are in flying mode, and there you go. The gravity in the air is not perfect, right? But it would require a bit more code to do that. Do you have any questions about that code or, the logic I put in there? Anything? No, it makes sense overall?
Yeah.
Cool. So for everyone watching, that code I'm showing here, the steering behaviors, take some learning, but they are very, very powerful. And we have a free tutorial on the channel, on the website. On the channel, if you look for steering in the videos, you will find it. How did it go for you?
Well, yeah.
Okay.
It's nice.
You're all proud of you?
No.
You did a very good job, actually. You learned very fast. Yeah. So everyone, I'm gonna go over really briefly the Kickstarter that we have going right now. Well, it went up again. We're running on Kickstarter to make a course to learn to code from zero with the Godot game engine. This is a paid course. Someone asked me about precision because I know this can be confusing. The course is paid, but as usual, we make free content, it on the channel, on our website, on GitHub, and we contribute to Godot. We do lots of stuff. And we do that thanks to those projects and paid courses, right? Those are what allow us to also make other things. And of course, if you want a very good course, you need to spend a lot of time on it, and that takes budget and all. There are other persons in the team. You can find a link in the description to check all the details of the campaign. Actually, what did the computer restart? The screen turned off.
It's
okay.
left, bro.
Yeah. Excuse me. I'm just going to put back the chat. All right. And so as part of this project, we're doing something for the Godot community. This is an app that is going to be free and open source because we reached our stretch goal of 50,000 euros. This app is going to allow anyone in the community and any teacher to make interactive courses to learn the GDScript programming language. You have a mock-up. I can show you. I can't show you that the technology works, but it does right now because it would be a bit complicated. How do I add a new instance of Godot? There we go. And Godot Live Editor. We are just in the process of making all the interface, so it doesn't look like much, but there's quite a lot in there. Where is the interface? Code editor is there, the lesson panel, and those kinds of things. So if I go to a lesson here, you can see there's a lot of stuff. What's happening? While in the process of working on it, so while breaking things every day. I know why. I know why this is happening. It's because while using Godot 3.4 to make it, applications Godot 3.4, if I don't open it here, we're going to have errors. There we go. So lesson.tscn. And there we go. It's such a mess right now. We're in the process of work on the interface. You have a code editor, you have a game running, and you'll be able to do interactive assignments in that. My teammate is working on this in parallel right now. So yeah, we focused on the technology first, and now we're making the interface, and we'll make it free and open source when it's ready. Of course, it's going to take a while with a free course to learn the GScript language to attract new people to Godot. So you can check the campaign, link in the description below. Consider becoming a backer to help us make more, to help this project get better. Every pledge counts. And with that, that's the end of the session for now. So question, does GD Quest stand for Godot Quest or Game Dev Quest? Initially, it was Game Design Quest, but it's whatever you want. Game Dev Quest would be the thing. So there you go. While also making a free and open source game, community-driven. You can see the previous video was about that, just a 2-minute video. And we'll make it community-driven. The idea is to turn this into a roguelite eventually. This is the final project for this course, but it's also something we want to build into something larger. Yeah, what do we have here? If you want to play a bit while we say goodbye. Thank you everyone for watching. If you have any questions, you will also find a link to our Discord server in the video description. And with that, thank you kindly for watching. Be creative, have fun, and we'll see one another in the next one. Bye-bye.
Bye-bye.